This video is about the implementation of Quicksort in sorting algorithms. Sorting algorithms are used by computers so that data may be easily searched for later on. Other sorting algorithms, such as bubble sort and linear sort, are tedious and take a long time. Quicksort, on the other hand, uses the idea of recursion. Recursion is basically the repetition of itself, such as when two mirrors are facing each other and reflect each other endlessly. Quicksort works by picking a pivot, then putting all the terms less than the pivot to its right, and then putting all the terms greater to the left. The pivot is then in its final position after this iteration. Then it will recurse on these less and greater subsets until all of the elements are in their final position. The succeeding pivot is picked by adding to the pivot index by 1 if it's the right subset, or subtracting if it's the left subset. To see it clearer, here are 10 people we are going to arrange. Our quicksort is going to pick a pivot based on the rightmost person in our subset for the first iteration. In this case, the rightmost person is number 7, so he will be the pivot. Quicksort will check who is greater than him, which are 9, 10, and 8, and will move them accordingly to his right. 7 is now in his final place. We now have two subarrays, the people to the left and to the right of 7. Let's check the one on the left first. 1 becomes the new pivot. Since everything is greater than 1, we move them all to the right of 1. Since 1 does not have anybody to his left, we move on to the ones on his right. 6 becomes the new pivot, since he is the one index to the right of 1. We repeat the procedure. We recurse on the left subset of 6, where 4 is the pivot. Since 5 remains the only one in its subset, it is considered to be in its final position since there are no other numbers less than or greater than it. We recurse on the left subset of 4 with pivot 2. The logic for 5 applies for 3 too. Finally, the left subset of 7 is in order. Let us move on to the right subset. Nine becomes the pivot and 8 is moved to the other side. Since 8 and 10 are now also alone in their subsets, they are considered to be in their final position. We have now successfully sorted our people! Quicksort can be varied by the choice of pivot, and its running time is heavily dependent on your luck with the pivot's position with every subset. Its worst case is sorting a set with a few unique values. However, it has a separate version that deals with this case. The worst running time for Quicksort is n squared, while its best case running time is n log n. As stated earlier, this is relatively faster compared to the other sorting algorithms. That's it. We hope you learned something from us today.